Did you know that the world's tallest wind turbine, the Max Vogel Wind AG, located in Germany, has the height of 2.5 Statues of Liberty? Imagine the dazzling dizziness you would experience when you look up at it. Now, if you've ever woken up at 4:30 a.m. and had a random thought about how wind turbines are made, join us as we explore how these giant machines are made. Wind turbines aren't just gigantic towers built by curious engineers for human aesthetics. They are built to harness the power of the wind to create electricity. In the US, for instance, wind power has reached a generating capacity of 136 gigawatts as of 2021, and it supplied 9% of the US electricity generation, meaning that it powered about 39 million homes. This is impressive. Now, the first known wind turbine used to generate electricity was created in Scotland by Professor James Blyth. His wind turbine was just 10 meters high, and it was installed in the garden of his holiday cottage in Marykirk. Blyth used the wind turbine to charge accumulators in order to power the lighting in his home. Fun fact, this made Blyth's cottage the first house in the world to have its electricity powered by the wind. But what's more interesting and perhaps funny is the fact that the professor offered the surplus electricity produced to the people of Marykirk for lighting the main street. But guess what? They turned down his offer because they believed that electricity was the work of the devil. It shouldn't be surprising though, because people had a lot of superstition for new inventions those days. But since then, wind turbines have grown and advanced, with each one more gigantic and powerful than the previous ones. So, we come to the big question: how are wind turbines made? The first thing you have to know is that there are two types of wind turbines. Some are land-based, also called onshore wind turbines, and others are sea-based, known as offshore wind turbines. Offshore wind turbines are, however, larger with bigger generating capacity and are faster and consistent at sea. Now, a wind turbine consists of four basic parts: foundation, tower, nacelle, and rotor blades. But all of this combined has about 8,000 parts needed to assemble the machine. To build a wind turbine, the first thing to do is lay the foundation. For land-based wind turbines, developers would have to select a suitable site to construct the wind farms. Next, they'll have to level the ground and lay down a very thick concrete foundation, which consists of about 600 to 1,000 tons of concrete, as well as 165 tons of steel. But the foundation can take many forms depending on the nature of the site. One such form is known as the shallow mat extension, which is simply a gigantic round-shaped disc made of reinforced concrete. It is quite easy to build and the construction period is short, but it requires a lot of excavation and is not environmentally friendly. Another form of foundation is the ribbed beam foundation, which uses less concrete and steel and is more structural and elegant. However, this type of foundation is more complex and difficult to construct. But what about offshore turbine foundations? Well, they come in two types: floating foundation and rooted foundation. Installing either of these two types of foundations on the sea is spectacular to watch. Like the name, floating turbines rest on floating foundations, anchored to the seabed using strong and sturdy mooring ropes. This foundation is, however, not common, but it causes less disturbance to the marine ecosystem. This is unlike the rooted foundation, which involves drilling a monopile, which is a 1,000-ton steel cylinder that is 80 meters high, deep into the sea floor. But how do these monopoles get on the sea? Well, through ships, of course. Huge ships transporting the monopiles arrive at the selected site, usually up to 200 feet deep. These ships then plant down legs to root it to the seabed and elevate it out of the water. Once that's done, the engineers use a crane to lower the monopiles into the water and drill it into the seafloor. It may sound easy, but the whole process takes a lot of work and causes a lot of noise and disruption to the marine ecosystem. Now, once the foundation has been successfully laid either on land or in sea, the next step is to assemble the turbine tower itself. For onshore wind turbines, A huge truck is required to bring in the components of the tower to the site, where it's assembled together, lying horizontally on the ground. This is because the tower's too big to be transported in one piece. The same process also applies to offshore wind turbines, where the pre-assembled towers are transported to the site in huge boats. The towers are divided into sections made from huge sheets of steel curled into cylinders that are up to 8 meters in diameter. For onshore wind turbines, a crane is used to lift the tower once it's been assembled on the ground horizontally. On the other hand, a crane is used to stack the different sections of the tower atop each other. For offshore wind turbines, the purpose of the tower, either on land or at sea, is to elevate the rotor blades above 30 meters from the ground, where winds are usually less turbulent and more conducive for energy generation. Now, the next thing to do is attach the brain of the wind turbine to the top of the tower using a crane. Whether it's onshore or offshore, the brain of the wind turbine, also known as the nacelle, is the most important part of the wind turbine. Made up of more than 1,500 components, the nacelle houses the generator,